Bienvenidos, Hushamdeed, and welcome to another NetAcad Introduction to Python course supplemental video tutorial. In this video tutorial, we're going to be taking a look at Lab 4.1.3.7, and we're going to be reusing some of our code from 4.1.3.6. And so here, we're going to be running some test data through two functions, and we're going to be checking to see how many days each month has and checking for the leap years, right? Because as you know, in a non-leap year, February has 28 days, but in a leap year, it's going to have 29 days. And so we're going to go ahead and take a look at the activity right now. As you can see right here, in each leap year, February is going to have 29 days instead of the regular 28. And this should be familiar if you've watched some of the previous tutorials. Again, this is just the Wikipedia definition of a leap year. And so let's take a look at the question, or I should say at the challenge here. So the estimated time, 15 to 20 minutes, may take you a little longer if this is your first attempt. Medium difficulty, and again, they give us some good instructions here, but there was one head scratcher, and I'll talk about that in just a second. So the scenario, we're going to write and test a function which takes two arguments. Now, you'll notice here it says that we have two functions, but the code that you used in Lab 4136 can easily be cut and pasted right into this function definition for is year leap. All right. Now, the function that we are going to be putting together here is the days in month. Now, this function is going to be passed two arguments. Here are the positional parameters. Again, the arguments would come down from the code here that invokes or calls the function. And then once those get passed into the function, those are our positional parameters. So we're going to write and test a function that takes two arguments. You can see the first one will be year, and the second one is going to be the month. And we're going to be feeding in some of this data down here. And it's going to return the number of days for the given month-year pair. Now remember, only February is going to be sensitive to the year value because up here we're checking to see if it's a leap year. And if it is a leap year, we're returning false. And so the function needs to be universal. Now, the initial part of the function is ready. In other words, the function definition that we have right here is ready to go. And this was the head scratcher. It says, now convince the function to return none if the arguments don't make sense. Now, we're going to be passing in some years here. So my interpretation of this, in other words, if they don't make sense, well, we're checking for leap years. So if the year, right, this test years column here, is less than 1582, that would not be a leap year because, again, the Gregorian calendar was not in existence prior to 1582. And if the test month that's going to get passed in, the integer value for that, if it's greater than 12, because again, there's only 12 months in the calendar year, right? January being 1, December being 12. And so that is my reading of that requirement. Convince the function to return none if its arguments don't make sense. So in other words, if the year is less than 1582 or the month is greater than 12, then we're going to return none. And that's how I'm going to handle that. So it says, of course, you can and should use the previously written code, and I do have that cut and pasted in already. I've removed the print statements because we're not going to need those this go around. We encourage you to use a list, right? So they're kind of giving you a wink, wink, nod, nod here, that use a list with the month's lengths. In other words, the number of days in each of the months that you would be that the calendar has. Again, remember, by default, normally, if it's not a leap year, February will have 28 days. And this is key, right? And we're going to have to kind of tweak the code a little bit when it is a leap year. You can create it inside the function. This trick will significantly shorten the code. And let's go ahead now. And again, I've just kind of wanted to recap what the requirements are, what we're looking at here. So let's jump over to the Integrated Development Learning Environment, or IDLE. And you can see we've got a file opened up over here on the right-hand side. You can clearly see my isYearLeap code for the function definition. I've already cut and pasted that in. And you can also see here that we're checking to see if the year is before 1582, because then we would return false, because that is not a leap year. So this is where our code is going to go. So let's dive in here and let's get to work on days in month. And so what exactly are we looking to do? Well, first and foremost, and let me go ahead, I like to put a new line in there, 1, 2, 3, 4. We're going to space in 4, and I'm going to say days. Well, the function name is days in month. I'm just going to call this num days in month, right? So number of days in the month. And we're going to create a list. And this was one of the hints that we were given. So, and that old saying, right? 30 days has September, April, June, and November, right? And so that's what I'm going to kind of be using. So according to that rhyme, January would have 31. Now, the second month in the year, and you can see the test months they're giving us here, right? And I'll talk about what this code down here is doing in a second, but you can see it's looking at February of 1900. It's looking at February in the year 2000. It's looking at January in 2016 and November in 1987. And that's how those match up. And we can also see that it's checking to see if there's 28 days in February of 1900, 29 in February of 2000, 31 in 2016, and 30 in 87. And again, these are pretty much constant. Where we're really concerned and where the code is going to make a difference is for February of 1900 and February of 2000. Because remember, these are sort of those special use cases, those centurion years, as into whether or not it's a centurion leap year or not. All right, so normally February has 28 days, so March has 31, and then April has 30, and then we're going to go May has 31, June has 30 days, has September, April, June, and November. July is going to have 31. September, 30 days has September, has 30. And I'm going to double check this here as I'm doing this off the top of my head. October should have 31 because we've got Halloween. November is going to have 30, and December, which is the month I was born, is going to have 31. So let's double check this here. So 31, 28 for February, 31 for March, 30 for April, 31 for May, 30 for June, 31 for July, 30 says September, April, June, and November, 31 for August. I figured I'd made a mistake in there. August, and then September has 30. I think I'm one off here. September has 30. October has 31. November has 30. And then December has 31. And we'll stretch this out here just a skosh to keep all of that on the same screen. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So all 12 months are in there. Hopefully I've got that laid out properly. Again, we're really concerned with February, right? The leap year. That's kind of the entire crux of the activity here. But I want to make sure that we're accurate with everything. All right, so now that we have that in here, now I'm going to address this requirement right here. The initial part of the function is ready. Convince the function to return none if the arguments don't make sense. So my read on that is if the year is less than 1582 from these years that are being passed in here, or and is it the month, or if the month is greater than 12, right? Because if the month is greater than 12, then it's not a legitimate month. And if it's the number is less, or the year is less than 1582, we can't calculate if that's a leap year because that's not, the Gregorian calendar did not exist. So this is where I'm going to say return none. Now, what's the next case that we need to take into account? Well, remember, we have to check to see if it's a leap year, right? Because that's where we're going to probably call this function here where we say is year leap. So we're going to check to see if it's a leap year and if the month is the second month, because that's what we are. And again, I'm kind of looking at this, thinking this through here. So I'm going to handle this with an elif, right? So I'm going to say elif is year leap. And again, we're going to put the year in there because this is where I'm invoking the function call to is year leap. And so let me take a step back here, right? So we're inside this function right here, right? Days in month. Because if we look down and let's kind of, didn't want to do that. I'm sorry. I wanted to make that a little bit better. So let's divide the code, right? So we've got our function definitions up here, and then here's the code that's kind of going to run and drive our testing. And so you can see that in terms of the calls to functions, the function call that gets made and then the result of that function call that's captured is days in month. In other words, it's the function that we're creating here. And the two arguments that get passed in are YR and MO for years and month respectively. Well, where are those values coming from? Well, they're coming from right here. Because remember, we're in a for loop, which means we're iterating a number. We're going to go through a number of iterations here, and that number is driven off of len of test years. Well, again, it's the length of the list, the number of elements in the list. If I count the elements, it's 1, 2, 3, 4. Remember, this is counting the length or the number of elements. It is not referencing the index position, which would have been 0, 1, 2, and 3. So really, what this is saying is range 4. And so we already know that our values that we would be looking at in range 4 are going to be what? How could we test that? Well, I'm going to leave the drawing up there. If I just came over here and I said for I in range 4, print I, those are the values we're going to get. We're going to get 0, 1, 2, and 3. And so when we reference elements in a list, that reference is done by the index position. And this can sometimes become a little confusing because learners will see these I's here and they'll think, oh, well, it's 1 and then 2 and then 3 and then 4 because that's how we counted the length of the test year list, but that's not the case. Remember, accessing an element in a list is done by the index position of that element in the list. And with Python, the lists begin, the first element is index position 0, which is why the range command is a beautiful way to go through and iterate over all the elements in a list based off the length of that list, because we know that the left-hand side of the range, which would 0 in this case, because we don't have 2 arguments that we're passing to the function here. It's 0 by default when not there, and it's this number minus 1. Remember, it's not inclusive of that number. And so you could have also written that range function like this, right? Although no reason to do that because that is your default. 0 would have been the default left-hand side argument. So we just simply have 4. But remember that it stops at 3. It's not inclusive of 4. And these I's right here will both first be 0. The first iteration through will both be 0. And so for the year, we're going to use 1900. Whoops, sorry, I kind of went through it there. And for the test month, we're going to use 2. So February of 1900. Now, the test results, we can reuse the I, because again, it's our first iteration through and we're testing that first element along with the first elements in test month and test years. And so we check, we assign what gets returned from the function call to days in month, and we pass in the first year, the first element in the years list and the first element in the month list. And then when that comes back, we're checking to see if the result that was returned is equal to test result I, which the first time through, if it's 0, we're going to check to see, are there 28 days in that month? And that's going to be based off of the code that we're getting ready to drop in here. So my elif is going to be checking to see, and this elif and that statement right there is going to call this function, because I need to know, is it a leap year or not? Once I've tested to make sure that the year is after 1582 and is a month that is less than the number 12, right? And I could probably, and again, I could probably put in here and make sure the month is greater than or equal to 1. I could probably throw that in there as well, and I'll make that change here in a second. But to keep the flow going here, we call is leap year, and is leap year based on whether or not it's a leap year, and we know this code to be faithful and true already. So whatever we have returned from that is what we capture, that we're going to capture, or I should say test for down here. So if it's a leap year, and if the month is equal to 2, because if it's a leap year and the month is equal to 2, then how many days are we going to return? You know, and we kind of reverse engineer that. That's what I was doing. I was looking down here, you know, thinking through what are we testing for, and then how would I do this? So if it's a leap year and it's February, we know that by the Wikipedia definition, it's going to have 29 days. And so we would do the sort of that logical or testing, or and testing on that one. And that kind of gives us the code that we're looking for. So if it's not before 1582, or the month is, and I actually, here's what we'll do. If it's, or if the month is less than or equal to 1 or greater than 12. There we go. So if the year's before 1582, or the month is less than, and actually I don't want less than or equal to, if it's less than 1 or greater than 12, we're going to return none. And that kind of checks to make sure that we don't have bogus information being passed in here. So if we pass these checks right here, right? So if the year is not less than 1582, and it's not less than 1, and it's not greater than, the month is not greater than 12 or less than 1, what we're going to do is we're going to check to see. Otherwise, is it a leap year, and is the month that we've been given equal to 2? Because if it is, we're going to return 29, because that's what we're testing for right there, right? So remember, if it's a leap year, by definition, it's got 29 days. Now, we're going to need we need to cover the case where it's not a bogus piece of data being passed in. The month of the year are not bogus. And we also need something to catch the fact when it is not a leap year in the second month, right? Because there could be leap years where it's not the second month. And so we need to catch that as well. And so then we're going to return. So if it's not a leap year, then we would want to return. And here's where we're going to say, is it going to be the days, the number of days in the month because we're returning back. I think it's going to be the number of days in the month, num days in month, and we want the month minus 1, because that's going to take into account, and again, I'm just looking at this right now to make sure that this makes sense. So if it's a leap year and it's the second month, we're going to return 29 days. Otherwise, and again, this would be if it's a leap year. If it's not a leap year, let me run this really quick, because now I'm wondering if my logic is correct. We got invalid syntax here. Where at? Oh, wait, sorry, I left out the month. There we go. All right, so let's hit F5, and let's take a look at the code. We get okay, 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 okay. So second month, so February of 1900, the test came back that it does have 28 days. The leap year in 2000 came back and it would have returned 29. And then we've got the January 31st of 2016, for 2016 came back okay. And then we've got November 30th of 1987, and that came back okay. And then that should be it. I think, let me double check here real quickly. This one got a little complex there. And let's see, let's make sure we've got everything. Use a list fill with the month's links. So that should do it. And again, this sort of final catch-all here is we're basically looking at the list, right? You can see here, number of days in the month, and then we're indexing based off the month. And the reason we've got to do that is because the index position is going to be 0, but the month numbers are not indexed that way. And that's what I thought was going to happen. Okay, so let's do this. I'm going to put something else in here. Let me put in some other, we'll put 92, and then we'll put 1600, and then we'll put 1500. So I'm going to add 3 things in there, and we're going to make them all February, because that's what I'm kind of interested in. And let's see, we'll say 28, and then 28, and then 28. Because again, I'm checking, we can check to see which one of these should be a leap year where we add in, because it'll test false if that's not the case. Let's take a look here and do this. And so, yeah, it looks like 92 failed, 1600 failed, and 1500 failed. And I'm assuming if we did 29, 29, 29, that if I ran this through, and again, all I'm doing is just pushing through. So for 1500, which was our last one, so wait a second. Oh, and 1500, I'm sorry, 1500 is failing because it's less than 1582, right? So irrespective of what I put in here, it's not part of the Gregorian calendar. So maybe we ditch that and put 1592 and then rerun this, and let's see what we end up getting here. And so that's what ended up happening there. 1592 failed because it would be oops, sorry, didn't want that. I wanted F5. It would be a leap year. And so there we go. So yeah, it was funny because as I got to this piece of the code right here, I knew that there was going to be a mismatch with these index positions, and I was trying to figure out in my head what that was going to look like. So yeah, the month minus 1, because again, I want to reference the month number minus 1 because the index positions are going to be 0, 1, 2, so forth and so on, all the way to 11. However, the way we reference the months here, it's February is 2, January is 1, November is 11, December would be 12, right? And so that's what we had to do in order to line those index positions up correctly. All right, well, we have a working solution to lab 4.1.3.7. That's going to do it for this lab. And again, pretty interesting, definitely not an easy task. So that's all I've got on this one. Let's move on to 4.1.3.8. I wish you the best of luck in your studies. Thank you so much for watching, and I hope to see you in the next video.